For this demonstration, all components of the DOMINO-E architecture are deployed on a shared cloud testbed. The virtual assistant service operates in its own namespace, while the coverage service and the satellite communication and resource management service are deployed together. After deployment, the user logs into the UAS interface and opens the chat to interact with the virtual assistant service. By typing a region of interest, the user defines the observation area. We choose Sichuan in China, an area frequently affected by flooding. The user can also define the period of interest and fine-tune and validate all possible parameters suggested by the virtual assistant. For this scenario, 2 Earth observation satellite constellations were included: Constellation Optique 3D, CO3D, and Pleiades Neo. When the user submits the request, the virtual assistant service transfers it to the coverage service, which is responsible for dispatching and scheduling the request. The coverage service confirms receipt and registers the new user request within the system. In the detailed view, the user can see the request displayed on a map. The coverage service divides the target area into several smaller programming requests, each managed independently. A progress graph on the right shows the estimated completion timeline of the overall coverage. Each programming request is assigned to a mission chain, which further divides it into smaller acquisition areas. When the user selects follow-up, the coverage service retrieves updated planning data from the mission chains. Completed acquisitions appear on the map as darker polygons, while pending ones remain highlighted. After updating the coverage map, the user triggers the recomputation function, which recalculates completion estimates based on the real coverage achieved at a certain point in time. The system retains historical data while updating forecasts for the remaining acquisition period. Once per day, an automatic redispatch is triggered. Comparing the first and second dispatch results, 2 programming requests originally assigned to the Pleiades Neo constellation were cancelled and resubmitted to CO3D, reducing total completion time. Following the redispatch, the coverage service communicates updated contact needs to the SCRMS, reduces the number of booked ground station slots, aligning the communication plan with the updated coverage requirements. All these operations are executed automatically, making both coverage planning and communication updates fully autonomous processes. Following the validation run, the state of both the coverage service and the SCRMS is analyzed to confirm correct interaction. Within the UAS simulator, the user request shows approximately 20% total coverage, with several programming requests cancelled and redispatched to alternative mission chains. On the final day of acquisition, contacts thus need to be increased for CO3D while remaining stable for Pleiades Neo. The resulting graphs show the evolution of contact needs for both constellations. The close alignment between required and booked durations confirms that the communication plan remains optimized throughout the scenario.